Okay, let's get started with example 9 here. We have to find the coordinate of any horizontal tangent, so we know that that implies derivative, and also find the equation of any horizontal asymptotes, which is something we haven't done in a while. Alright, so we'll start off by finding the coordinates of horizontal tangents. Remember, that's where our derivative will be equal to 0. Okay. So we're going to have to take the derivative of this using the chain rule. Alright, so that says g prime of x equals 2 times arctan of x, alright, times the derivative of arctan of x, or inverse tangent. That's 1 over 1 plus x squared. That one's not too hard to remember. If you don't know it, make sure you memorize it. Alright, so there's our derivative. We can maybe write it as a fraction altogether. G prime of x equals 2 times arctangent, and I'm just going to write it as inverse tangent because it's shorter. Alright, 2 times arctan over 1 plus x squared. And we're trying to decide where that is 0. Alright, so we know that's going to be where our numerator is equal to 0, and the denominator isn't. Alright, so we keep going here. Set the numerator equal to 0. 2 times arctan of x equals 0. Divide 0 by both sides by 2. We get arctan of x equals 0. So this is asking, where does tangent equal 0? And because you know about the unit circle and you know your trig functions, you know that's going to take place when x is 0. Now if we plug 0 into our g of x function, right, if we plug in 0, arctan of 0 is 0, so that is 0 squared, which is 0. So the point, the coordinate at which we have a horizontal tangent, is the origin. Alright, now the second part here is asking for horizontal asymptotes. If you remember when we did the limit items, if we take the limit as x approaches infinity or negative infinity of our function, that'll give us our horizontal asymptotes. Alright, so if we try, and remember our properties of limits also, if our function is squared, we can, oh, that says arctan. Alright, we can move the power outside of the limit. Okay, so instead of arctan squared, we can take the limit as x approaches infinity for arctan. Alright, so if you're imagining, maybe you don't know the graph of arctan as well as you know the graph of tangent. So the graph of tangent, alright, it looks something like this. And so we're trying to discover, and maybe if you don't want to think about where are the horizontal asymptotes of arctan, maybe you could instead think about where are the vertical asymptotes of tangent. Alright, and you should remember from our previous studies that that would be at pi over 2. Alright, so pi over 2, and we're going to square that. So it has a horizontal asymptote at pi squared over 4. There's a horizontal asymptote there. Alright, x equals that. Alright, we also have to consider the opposite case. So where else? So where's the limit of g of x as x approaches negative infinity this time? Alright, so where is tangent approaching negative infinity at? And that is negative 1/2 pi. Alright, and if we square that, just like the last example, alright, we get pi squared over 4. So it's the same place. So either way, sometimes we can have two different horizontal asymptote numbers, but in this case we have the same thing. Alright, so we have two more examples to cover. Alright, rewrite this as an algebraic expression. Alright, arc cosine. We're thinking about an angle there. So this is our ratio part. So we're trying to figure out at what angle is arc cosine that ratio. Okay, and if we want to make it more like a ratio, we could rewrite it as tangent of arc cosine of x squared over 1. Or we can make it look more like a ratio. So if we sketch a quick little picture and draw an angle here, cosine is adjacent over hypotenuse. Alright, so we get x squared is the adjacent, hypotenuse is 1. Using the Pythagorean theorem, you can find the other side. And doing that, I believe you should get square root of 1 minus x squared squared, which would be x to the 4th. If you don't believe me, do it for yourself. Alright, so then we need to find the tangent of that angle. Tangent is opposite over adjacent. Yep, opposite over adjacent. Okay, so then that would just be square root of 1 minus x to the 4th all over x squared. So this whole thing, rewriting that as an algebraic expression, looks like this. So it might be useful to rewrite this if we were looking for zeros or undefined values, or maybe even to take the derivative. So we are going to get an example of that in example 11. Here's a multiple choice question. So we need to find the derivative of this. Okay, sometimes I won't write by simplifying first. I'll just write find the derivative of this. So normally if we were going to use the chain rule, derivative of cosine is sine, or negative sine of x, or sine of this whole thing. But if you look at your choices, none of them involve sine. So, since it follows our previous example where we had to rewrite a trig expression in terms of an algebraic expression, we'll probably have to do that here as well. Alright, so we have to think tangent, the inside part, that's already written as a ratio. So tangent is opposite over adjacent. So we draw our quick sketch here. Here's our angle. Opposite is x. Adjacent is square root of 6. Okay, solving for the other side, we get square root of x squared plus 6. And we want the cosine of that. So that would be adjacent over hypotenuse. So another way of writing f of x without trig functions would be square root of 6 over square root of x squared plus 6. Now it might be easier to take the derivative. You could use the quotient rule here, but because this is a constant, part of that's going to turn into 0, so I'm going to go ahead and use the chain rule. So I need to rewrite my function. This would be x squared plus 6 to the negative 1/2. Okay, now it's a little bit easier to see the power rule there. Alright, so the derivative of f would be negative 1/2 times square root of 6, or square root of 6, negative square root of 6 halves, okay, times x squared plus 6 to the negative 3 halves, because don't forget to subtract 1 from your power, alright, and times the derivative of the inside, which would be 2x. Now we can start to simplify this. Alright, I could cancel out these 2's. Maybe I should rewrite it because I notice all of these have fractions, so maybe I should try to put this together as a fraction. So it would be negative square root of 6 times x all over x squared plus 6 plus 6 to the 3 halves. And we look and see, does that match any of our answers? Why, yes it does. It matches example or letter E. And so then we're super excited because one of our answers actually showed up. Alright, so this is a 10-minute video. You should try to spend at least 10 to 20 more minutes working on your worksheet.